Hi students, today we are going to see NCERT solutions for chapter Electrostatic Potential and Capacitance. So before I could start this, I want to introduce some very important formulas in this topic. So let me start with Coulomb's law. So according to Coulomb's law, the electrostatic force of attraction or repulsion between two charges is directly proportional to magnitude of product of two charges and inversely proportional to square of the distance between two charges. So here k is the proportionality constant and the k is nothing but 1 upon 4 pi epsilon naught. Okay, and the numerical value for k is 9 into 10 raised to 9 Newton meter square per Coulomb square. So we can write Coulomb's formula or Coulomb's law in order to find the electrostatic force of attraction or repulsion between two charges. F is equal to k q1 q2 upon r square, where epsilon naught is the permittivity of free space, is equal to 8.85 into 10 raised to minus 12 Coulomb square per meter square Newton. So if you represent Coulomb's law in vector form, we'll get force on charge first due to second is equal to k q1 q2 upon r21 square, where unit vector pointing or directing from charge 2 to 1, that is r bar 21 is equal to r1 minus r2. Here if you move towards the electrostatic field, so the basic formula of electrostatic field is nothing but E is equal to electrostatic force per unit positive charge. But if you solve the electric field due to a point charge, then the formula will be k q upon r square. Here don't forget to write k is electrostatic constant and it is nothing but 1 upon 4 pi epsilon naught. Now next, if you find the electric field due to circular loop of charge at distance x from the center, if the r is the radius of the center, then electric field E is equal to k q x upon x square plus s square raised to 3 by 2. Okay, and already dear students, we had this expression in our previous lectures. So electric dipole, my dear students, electric dipole is nothing but magnitude of product of one of the charge and distance between two charges. So the formula is, for electric dipole moment, P is equal to Q into 2A, and this is the formula for electric dipole moment. And the electric dipole is nothing but arrangement of two equal and opposite charges separated by some finite distance. And then this is the formula for electric dipole moment, that is P is equal to Q into 2A. Then electric field at an axial point of dipole, already we had this expression in our previous lectures. So E axial is equal to K 2P upon R cube. And similarly, if you find for equatorial point of dipole, then we know that it is half of the axial point, that is E equatorial is equal to K P upon R cube. Then the torque acting on dipole when it is placed in uniform electric field, it will be torque tau is equal to P into E in vector form, that is PE sin theta. Then potential energy of a dipole in uniform electric field, already we had this expression in our online classes. So U is equal to, that is electric potential energy or potential energy of the dipole is equal to minus PE, where P is dipole moment and E is electric field. Now electrostatic potential. What is electrostatic potential? It is the amount of energy required to bring the unit positive charge from infinity, and already we had this expression. The potential, electrostatic potential due to point charge is nothing but V is equal to K. So here again K is nothing but 1 upon 4 pi epsilon naught charge upon distance. So V is equal to KQ upon R. But the potential at an axial point of the dipole is V axial is equal to Kp upon R square minus A square. Here once again K is nothing but 1 upon 4 pi epsilon naught. If the 2A is very less than R, that is R is the distance between center and that point. If it is greater than the distance between 2 points, that is 2A, that is length of the dipole, then the V axial is Kp upon R square. And we know that electric potential at an equatorial point is always 0. Okay, then next point we have done in expressions, relation between electrostatic field and potential gradient. Then the formula for it, the electric field is always equal to negative of the potential gradient. So E is equal to minus dV by dr. So electrostatic potential energy we have already calculated. The electrostatic potential energy for 2-point charges is always U is equal to K Q1 Q2 upon R. Then we have seen Gauss theorem. What is Gauss theorem, my dear students? So before that, I could explain, or I want to explain the electric flux. Electric flux is nothing but amount of electric field lines passing normally through the given area. And the electric flux, the magnitude of the electric flux can be calculated by using formula phi is equal to line integral of closed path E ds, where E is electric field, d is surface area. Then we have seen the Gauss theorem or Gauss law. According to Gauss theorem, the number of electric flux or total electric flux passing through any closed surface is equal to 1 upon epsilon naught, that is 1 upon permittivity of free space times of the total charge in the closed surface. That is, this is the formula for electric flux. So electric flux passing through any closed surface is equal to 1 upon epsilon naught times of the total charge. Here Q is the total charge in the surface. So phi is equal to line integral of closed surface E ds, where E is electric field, ds surface area, is equal to charge upon permittivity of free space. Isn't it? Here it is already given. Then electric field E due to infinitely long straight wire. Already we have done this expression because this is the first application of the Gauss theorem. If you see, or if you want to learn it again, just see or just subscribe my YouTube channel. You can see this expression is there already. So E is equal to lambda upon 2 pi epsilon naught R. Here lambda is linear charge density, epsilon naught is permittivity of free space, and R is the distance of that charge from distance of that point from the charge. Then we have done electric field E due to thin infinite plane sheet of charge. This is the second application, and this application already we have used to derive the expression for capacitance of parallel plate capacitor. So E is equal to sigma. Sigma is charge density again divided by 2 epsilon naught. Epsilon naught is permittivity of free space. Then electric field between two thin infinite plane parallel sheets of the charge, and it is nothing but E is equal to sigma upon epsilon naught. And this electric field between two thin parallel plate is always half, or we can say always double of this, isn't it? Means if you calculate the electric field between two plates, then it is always double of electric field due to one single plate. So that for single plate we can write sigma upon 2 epsilon naught, or for double plate, that is in between the two plates, sigma upon epsilon naught only. Then electric field due to third application of Gauss theorem, electric field due to uniformly charged spherical shell. For that purpose we have seen three types of applications. First, here R is the distance of that point where electric field is to be determined from the center of the circle or center of this shell, okay, spherical shell, and capital R is the radius of the spherical shell. So here this R is the distance of that point from center, and R is the radius of the spherical shell. If the point charge R, or if the R is greater than capital R, what does it mean? The point P is outside the shell, that is first point in third application. Then the electric field will be K Q upon R square. Don't forget K is nothing but 1 upon 4 pi epsilon naught, that is 9 into 10 raised to 9, Q upon R square. And if R is less than R, what does it mean? Iska matlab hai the charge is inside the sphere, and if charge is inside the sphere, then electric field is always zero because there are no charges inside the spherical shell. Then if R is equal to R, means the point P where the electric field is to be determined, that point P is on the surface of the shell, means R is equal to R. So E is equal to KQ upon R square. Here R is the distance. So these two formulas are nearly same. Then capacitance we have seen. Capacitance, it is the property of capacitor or ability of capacitor to store charges at high potential. So capacitance, it is an alternative definition is that in the form of mathematical expression. Capacitance is nothing but charge per unit potential, and the SI unit is farad. So 1 farad is nothing but 1 coulomb upon 1 volt. So isolated spherical conductor, already we have done this expression. The capacitance of isolated spherical conductor is directly proportional to radius at constant 4 pi epsilon naught. So if you increase the radius, capacitance will also increase. Okay, then parallel plate capacitor, capacitance of parallel plate capacitor C is equal to A epsilon naught upon D. Here don't forget to write K. for air we have taken K is 1, that's why we have not written K here. So C is equal to A epsilon naught upon D. Okay, and if any for any particular medium we can write C is equal to A epsilon upon D, where epsilon is equal to K epsilon naught, and K is a dielectric constant in this case. Okay, then here if you connect capacitors in series, then the formula will be reciprocal of equivalent capacitance. This will be the equivalent capacitance. The reciprocal of equivalent capacitance is equal to reciprocal of sum of all individual capacitance in series combination. Then if you connect capacitors in parallel combination, then the equivalent capacitance C in series in parallel combination is equal to sum of the individual capacitance connected in parallel. So my dear students, this capacitance in series and parallel is totally opposite to the resistance. If you connect resistance in series, so it will be sum, but here in capacitors in terms of it is we have to take the reciprocal. But if you connect resistance in parallel, it will come reciprocal, but in capacitors, in terms of capacitors, it will be sum only. Now already we had the expression in online classes, energy stored in the capacitor. So there are 3 to 4 formulas we have derived in that case. So E is equal to half CV square, or E is equal to half QV, or half Q square upon C. Then energy density also we have done, U is equal to half epsilon naught E square. Then if you want to find the common potential, then V is equal to C1 V1 plus C2 V2 upon C1 plus C2. Just remember these all formulas. If C with conducting slab between the two plates, then C is equal to epsilon naught A and divided by D 1 minus T by D, where epsilon naught A upon D minus T, where here we know that epsilon naught permittivity of free space, A is area, D is distance between two plates, and T is the thickness of slab, isn't it? And this formula is applicable when the thickness of slab is less than the distance between the two plates, where C is the dielectric slab between C with the dielectric slab, means if you, in order to find the capacitance of parallel plate capacitor with dielectric slab between them, then we can use the formula C is equal to epsilon naught A D minus T 1 minus 1 by K, where K is the dielectric constant. So hope this all formulas you understood very properly. So my dear student, it's request you write down, you note down all these formulas with giving proper numbers, and just do learn it. Next video we'll see or we'll start the NCERT solutions. Thank you.